Okay, really quick, I'd like to go over the last couple problems. Okay, on number 7. Okay, the first thing we're looking for, the independent and the dependent variable. The independent is your x, and your dependent is your y. Okay, now, what is dependent on the other? Is time dependent on the height, or is the height dependent on the time? In this case, the height is dependent on the time. The height is going to go right here. Okay, so that's the height. Okay, and the amount of time in seconds goes on the x-axis. Okay, so the independent variable is my time. Okay, the dependent variable is my height. Okay, now make sure you read everything here. Read real carefully. Okay, the rocket flew over the rooftops of Justin's house, which is 20 feet high. Okay, we'll come back to that here in just a second. Okay, read these conditions. So it has to go at least 20 to go over the height. To go over the house. Okay, it cleared the roof of the house by almost 6 feet, so it's almost to 26. It took 1.5 seconds for the rocket to reach heights of 15 feet. So at 1.5, it's at 15. Okay, the rocket was in the air for 6 seconds, so it's going to go up and come back down to right here. So halfway in between 0 and 6 seconds is 3. So I'm going to draw my axis of symmetry. Okay, now it's going to go up to at least or right around 26. So we have a point there. That's the vertex. Now, how far is this point from the axis of symmetry? It's 1, 2, 3. So you can go on the other side. 1, 2, 3. Okay, it started from the ground. Okay, so at 6 seconds it's going to hit the ground. So your parabola should look something like, oops, I'm kind of not very good drawer, but there it is. Okay, now what ordered pair represents the y-intercept? Where does it cross the y-axis? Crosses right there. That point is at the x is 0 and the y is 0, so that point is 0, 0, or the origin. Okay. What does the y-intercept mean? Okay, that means the rocket started there, so that's the starting point. Just like linear equations, the y-intercept here in most situations is the starting point, or where it was launched from. Okay, when will the rocket be 20 feet high? Approximately. So that's sometime, if you look at the graph, it's sometime around 2 seconds. But with something that goes up, what also happens? It has to come back down. Okay, so if it's at 2 seconds, it's probably also around 4 seconds. Okay, so that's number 7. Number 8. Okay, number 8 and 9, there's a couple ways to do this. Okay, first of all, let's put our x down here. Now, it's going by 1. So I'm going to start with 0, 1, 2, 3, 4, 5, 6. Okay, now, okay, there's a point at 0, 0. Point at 180. Okay, now, these right here, they're going up. I'm going to count by 20. So I'm going to go 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220. Oops, 220. Okay, this is time in seconds, and this is height in feet. Okay, when it says label, make sure you put that. So now let's plot the points. 0, 0, 180, 2, 140, 3, 180, 4, 200, 5, 200, 6, 180. Now, if you notice, it's going up and then starts to come back down. The vertex is somewhere right in here. Okay, so I'm going to draw my axis of symmetry kind of right down in the middle between 4 and 5. Okay, so that means, okay, you have a point, you have a matching point, you have a point and a matching point, and then 0, 0. Okay, now I'm going to show you another way to look at it here in just a second, but if you're just drawing it, it will look like this. Okay, so there's my graph. It says, using your calculator, write the equation that models the above problem situation. Okay, we're going to take a little bit of time and look at a couple of these right before we take the test, but this should be really easy. Okay, now we're given a table, and we've done this with linear functions, and it's the same thing with quadratic functions. Okay, what I'm going to do, turn on my calculator. I'm going to clear it. Second plus 712. Okay, I'm going to go to stat, and I'm going to put this table in my stat. Stat, edit, put the x's in L1. So 0, 1, 2, 3, 4, 5, and 6. And I'll put my y's in L2. 0, 80, 140, 180, 200, 200, 180. Okay, now I have my table. Okay, now I can get my calculator to tell me what the equation is. Okay, we do it the same way we did for linear functions. Stat, calc, but instead of linear regression, we're going to go to 5, which says quad regression, which is quadratic regressions. 1, 2, go to 5, enter, enter. Okay, and here's my equation. My A is -10, my B is 90, and my C is 0. Okay, so the equation, let's look at it. Y equals -10x squared plus 90x plus 0. You don't have to put the plus 0. Okay, a couple things. You could tell by your graph, but you could also, once you get the equation, put that equation in y equals -10, excuse me, x squared plus 90x, and go to your table. Okay, start. Oh, I put something in there wrong. -10x squared plus 90x. Okay, go to my table. Okay, it starts at 0. It goes up, then comes back down. When is it going to reach 0, a height of 0? At 9 seconds. Okay, now we can look at our graph and answer this too, the one that we drew. We know it's at 80 feet at 1 second. Okay, but it also returns to 80 feet at 8 seconds. Or, once again, I could look here on my table because I just put it in there. At 1 second, it's at 80 feet. And at 8 seconds, it's at 80 feet. Either way, you can come up with the correct answer. Then the last one. Okay, first of all, the first question says, is it quadratic or linear? Let's just briefly plot the points and look at it. Okay, 216. Be somewhere way up here. 1, 4. 0, 0. -1, 4. -2, 16. Okay, just by plotting the points, is that quadratic or linear? Okay, it's a parabola, so it's quadratic. Okay, write the equation of the function. Okay, once again, let's go to stat. Stat, calc, or let me clear it. Second plus 712. Go to stat, edit, put the x's in L1. 2, 1, 0, -1, -2. Go over to 16, 4, 0, 4, and 16. Stat, calc, quadratic regression, enter. Okay. A is 4, B is 0. What is 0 times x? 0 times anything is 0. Okay, and C is 0. So my equation is y equals 4x squared. Simple as that. Hopefully that will answer any questions you may have. And like I said, I will look at putting in the calculator before we take the test on Tuesday and Wednesday. I hope this helps, and good luck.